Let's start today's class. So we were talking about the shift registers, and we have seen about two types of shift registers: serial in, serial out, and parallel serial in and parallel out. These two type of shift registers we have already seen. Okay. We have seen examples as well. 4-bit and 5-bit both we have seen. Yeah, and how data we can input the data in the register, we have seen that also, and how we can take the data outside from a shift register, we have seen that also. Okay, the registers can be serially, we can insert the data serially in, and we can take the data out serially, and we can insert the data serially, but we can take the data out parallelly. We have seen these both type of shift registers. This is a circuit diagram for serial input data, and we are taking the parallel output. We can use this available data. We can use this anywhere we want to use this output data. We can directly connect it. Okay. But in the previous case, when we were using serial in, serial out, we were not taking data like this. Rather, the data was moving from left to right. The data was moving like this. Okay, so we cannot take data outside directly, but the data was moving one bit by one bit. Okay, so this is the second type of shift register. So let's move ahead. Okay, so this is a standard shift register 74XC164. That is an IC. Okay, so there it has been standardized and an IC has been formed. So it is an 8-bit shift register. Okay, so you can see that how many flip flops are there. 1, 2, 3, 4, 5, 6, 8 flip flops are there. Okay. And the data, you can see that we are inserting the data serially. Okay, the serial inputs, there are two bits as the input, A and B. Okay. But the output is not output is not output is depends output depends on both the value of A and B, because the output is A into B complement. Okay, the output is A into B complement. So the output of this data, which is the serial input data, so for our shift register the serial inputs are A and B. Okay, and what we are feeding to our here SR has been used. Okay, so we can use JK as well, and I told you that the difference can be of delays. Okay, and the requirement of what requirement we want. So depending on that, it can be we can use the SR or JK. So here the JK has been used, SR has been used. Obviously, the D flip flop from the SR has been formed here. D flip flop SR से यहाँ बना लिया गया है. Okay. So what we have here, we have clock and clock. We have one input as the clock and the another input as the clear. Okay. But we have multiple nodes, at least three nodes, one node, second node, and third node. These are the three nodes. Okay, three nodes make one node, three node, five node means only one node. Okay, so this is like and clear itself is complemented. So clear is complement one inverter, second inverter, Okay, and we get the inverted signal here. And so this is the clear signal. If you want to clear this, you have to press the clear signal, and it will be all the flip flops will come to the zeros. Okay, and you can see that the output we are taking is parallel out here. So you can all the output we are taking out is parallel out. Okay, so from Q0 to Q7, all we are taking parallelly out. So this is the structure. Again, although what has changed is this is like one input, and it is whatever. Let me give it new name. Say X. This is X. So what is available here is X complement. Okay, and this has continued everywhere. So its output with a naught is going here, and the same S is going here. Okay, this is how we can make the D flip flop in the RSR flip flop. Okay, so the operation will remain the same. There is no change in the operation. So this is a standard serial in and parallel out IC 7074HC164. You can remember this IC number. Okay. So this tells us what this. If I ask what this IC is, this is an 8-bit serial in parallel out shift register. Okay. So this is the on the bottom side they have shown the logic symbol of that IC. So this here what has been shown is a waveform for all the input variations. Okay. So it is like similar what we have done previously. So I'm not going to explain it. You can read it by yourself. Okay. If you feel any problem in this, you are free to ask me. Okay. This will tell us the same thing, same story that we have already discussed. That's why I'm not discussing it again. If you feel any problem, you study by yourself. If you feel problem, you can ask me. Anyone having any problem? Okay. So the next type of the shift register is parallel in and serial out shift register. It means that we will insert the data parallelly, and the data we can take out is only serially. Okay. Data we can take out is serially. So this is parallel in and serial out. A 4-bit parallel in serial out shift register is shown. You can see here how many bits are there. Okay, so bits are decided by the number of flip-flops. You should remember this always. Okay, so this external circuitry, this doesn't decide the number of bits. Number of bits are always decided by the flip-flops. Okay, so there are 4 flip-flops, so we can say it is a 4-bit flip-flop, a 4-bit shift register. Okay, the circuit uses D flip-flops. Okay, D flip-flop हम SR से बना सकते हैं, JK से बना सकते हैं, and NAND gates for entering data to the register. We have used multiple NAND gates. ये देखिए यहाँ पर कई सारे NAND gate use किए गए हैं to enter the data. Again, we have a clear signal. If you want to clear all the flip-flop, just we have to keep the signal high, and all the flip-flops will become clear because there is no not. Okay, देखिए यहाँ पर भी कॉम्प्लीमेंट नहीं है, यहाँ पर भी इन्वर्टर नहीं लगाया, so it means clear signal is active high. If it is high means it will clear everything. Then clock is there. So you can see that the clock is positive edge clock. Okay. So the clock is positive edge, and then what we are giving is the inputs are D0, D1, D2, and D3. These four are the inputs. Okay. क्योंकि आपको एक बार में ही डेटा एंटर कराना है. सपोज इफ यू वांट टू एंटर 1 1 0 1, तो हम एक साथ ही सबको ये वैल्यू असाइन कर देंगे. D3 को हम 1 बना देंगे, D3 को 0 बना देंगे, और D1 को 1 बना देंगे, और D1 को और D0 को D1 कर देंगे. ठीक है. So all the same time, if you want to insert this data in this, you want to store this data 1101, you want to store this data, we have to assign this type of value, and as soon as the clock comes, all the value will be stored in the flip flops. Okay. So how it works, let's see, because this is different in little aspect. Okay, so as soon as the clock comes, so what happens, let me clear some things. Okay, you can see that. So there is one more signal, and this signal name is right bar slash shift. Uh, Similar signal we have seen for that up slash down bar counter. Okay, this is just to remind you, up slash down. Okay, and down was complement form. Okay, so what it means that, as I told you, this contains two information. If it is one, so it means that up equals to 1. It means it will perform the up counter operation of up counter. When it is 1, it means that down bar is 1. Down bar equals to 1, which means that down equals to, we have called this, it means that down equals to 0. It means down is not enabled, so down will not work. Okay, so this signal, we have written two things, but only one is active, one is performing at a time. Okay, so similar signal is here. Okay, what is here is right bar. Okay, the signal here is right bar slash shift. Here symbol is right bar slash shift. So what it tells, if it is equals to 1, so what operation this circuit will perform? This circuit should perform right bar is equal to 1 or shift is 1. It means shift equals to 1. So this will perform shift operation. Right bar equals to 1 means right will be 0. It will not perform the right operation. Right operation means we are writing in the register, we are storing the data. Okay, so if right bar equals to 1, so this will become right will becomes 0. It means we are not writing. Okay, to write, right bar must be 1. It means right bar must be 0. Okay, so if you want to write, we have to keep this signal as low. Okay, if you want to write, we should keep the signal 0. If you want to shift, we have to keep the signal 1. Okay, so this is for shift, this is for shift, and this is for write. Okay, I hope you understand the signal. Okay, so if we want to write, okay, first we write, then we will see how this shift. Okay, so if you want to write, what we have to make this signal, we have to make this signal to be 0. Okay, so let's the signal is 0. I made the signal 0 everywhere. So this is 0 here, and this is 0. Okay, so lot of drawing. Okay, so let me remove so that you understand the first drawing. Okay, so we have kept the signal to be 0. It means we are writing the data. So this would be 1 1. What data we want to write? 1 1 0 1. Okay. So this right bar is equal to 0. It means right is 1. So it means this signal will be 0 here. This signal will be 0 here. This signal will be 0 here. Okay. Alia, is there any question? You have raised hand deliberately or by mistake, I don't know. Okay, okay then. Okay. So this signal is 0. So let's see what will happen as soon as the clock will come. This flip flop is D flip flop. As soon as the clock comes, what will happen? This one available at the input will reach to the output. This will change to 1. Okay, this will change to 1. So first flip-flop has been evaluated how it is functioning because there are no logic circuit, extra logic circuitry here. It is directly connected to the flip-flop, and as soon as the clock comes, this data will be available at the
मेरी चप्पल छुड़वा
output.
लाना जाते में पर नंगे पैर होने वाला
Stop.
ले लो फेरी
Stop
फूट
your
ले लो
audio.
जोड़ लेना थोड़ा सा वहीं
Stop your
फिर
audio.
आराम से लेना चप्पल पप्पल से मंगा लेना अंदर से यार बहुत ज्यादा टूट गई है गली तक जा पाएगी ना हाँ वहीं इधर के पास तो हो जाएगा नंगे पैर जाएंगे तो नहीं तो फेविक्विक से वो थोड़ी जुड़ेगी भाई ले जाएगा
Farhan asks, you don't know that your audio became on, and how it become on? You should keep it silent. Okay. So yes. Okay. So first flip-flop has been evaluated. So no problem for that because there is no logic circuitry. Whatever the input is there, as soon as the clock comes, the input will be available at the out. Okay. Okay. So what we have here it was 0. Okay. So both the signals of an AND gate are connected to it. So it means 0 into 0, both are 0, and then complement, it means it is 1. So this signal is 1. So here it is 1. Okay, it is 1. And what about this D1? Okay. So D1 is 1. 1 and 1. What will be the output? Both are 1. 1 1 output will be 0. Okay. So this will remain the same. Don't worry for that. Okay. इसका performance जो है इस data पर depend नहीं करता है. Okay. So this will be decided by further operation. Then what is the output here for this flip-flop? Okay, since when clock comes, normally the delay of the flip-flop is much greater than the delays of these gates. Okay, like this maybe the flip-flop may be having a delay of 50 and this flip-flop may have 10 each. Okay, so the delays of this gates are smaller. Okay, so why I'm saying this, it means that when the clock comes, this data will not be able to evaluate, and before this what data was available here, it was 0 everywhere. Okay, so it was 0 here. Okay, so 0 and 0, this data will become 0 and 0, so the output will become 1. So 0 and 1, the output will become 1 here. Okay, so again when the clock comes, this will flow and it will become 1. Okay, before the clock came, the data was, this was 0, this was also 0. At the same time, this would be evaluated. Okay, at the same time this would be evaluated. What is happening here? So this output is 1. You can see that this output is connected to this and this output is 1. It means this is 1. The data input that we are using D2 here is 0. Okay, if you are confused in any way, what we can do, what you can do, okay, for this, I'm not using 0. Okay, I'm not using 0 for this particularly. Okay, just to tell you that even if it is anything, if it is anything, this will come, same D2 will come here. Okay, same D2 should come here. It should not change. Okay, for this I'm remove this data. Now the data is 1 1 D2 1. Okay, just for your understanding that D2 can be anything or D3 can be anything because the data can be anything. The same data should reach to the input of the flip flop. This is our purpose. Okay, so just to show this, I am using this data anonymous, not providing any value to this. Okay, so one has reached here. So another input is D2. For this NAND gate, another input is D2. So what will be the output? The output of this will be 1 into D2 complement. So the answer is D2 complement. Okay, or rather I write it by text. That will be even better. Okay, you understand it better. So I write it here by G2 and so this data is D2 complement. Okay, so here it was 0 before the clock comes. Here it was 0. So this would be 0 here and this is 1. So 1 and 0 the output is 1. Okay, so again the output here is what? Again these two are passing through this NAND gate and then going to the input of this. So 1 into D2 complement. The answer is D2 alone. You can see that, sorry, not the top one. Yeah. So you can see that this is the input that is coming here. Okay. So what I have shown you that whatever the input here, D1, D2, D3, whatever their values, the same value will reach here. Okay. I didn't use the 0, 1, 2 like that because it is independent of the value of one, D1, D2, D3. Because they can be anything. Data can be anything. Okay. So I think so now whatever was D2, now this data D2 will be available outside. Okay, so what we have used here for D2 is 0. Okay, so here will be 0 again. So 1 1 0 1. So here will be 0. Okay, previously here was 0. Okay, so the bottom side I have written the previous values. Okay, and the top side we have written the new written values. 1 1 0 we have written. We have seen how it is writing. Okay, and now it comes to the last. Okay, so what this input is connected. Anyone having any problem? Okay, so this data is connected here. So what this input is 0. If any input of the NAND gate is 0, the output is 1. Okay, so this data is 1 and this second input is, you can see that this input is moving here and it is going to connect here. So this D3 is there. Okay, let me show you this D3. So D3 and 1, the output will be what? Output will be 1 into D3 complement and this will result in D3. Okay, D3 complement. So here the output is D3 complement. Okay, and what is the output here? 1. So 1 into D3, the answer will be what? Here the answer will be D3 alone. Okay, so D3 is the input and the when the clock comes, so the D3 will be output. Here D3 is 1, so what we will have the output as 1. So these lower values, this and this, these are the previous state. Okay, and these values, these are the new states. Okay, if you have any doubt, you didn't get anything in this, if you want me to repeat, I can repeat this. Okay, so this is how we can write the data. Okay, so once again, quickly, without using any data, I can tell you how it is working. Okay, so first of all, remember that the delay of the flip flop is much greater than the delays of the each of the gate. Okay, when the clock comes, okay, so before the clock appearance, we have already cleared each and every flip flop. So every flip flop will be zero, all flip flop will be zero. Okay, we have cleared them. Okay, now, and this signal we have kept is how much? Zero, because we want to see the right operation. So and now I'm not giving any data to this D0, D1, D2, D3. I'm not giving any data to this. Okay, so directly for them I'm doing this. So D0 is the input. So D0 is here, and as soon as the clock comes, the output will be available here, here. Okay, so this output, this input and this output will have certain amount of delay. Okay, whatever the delay of the flip flop, let's say it is 50. So this will be available, this input after the clock comes, 50 nanoseconds after this output will be available. Okay, so after 50 nanoseconds. So what happened here? So these two are connected to this this NAND gate. Both inputs are connected to this line, means 0 0. This line is 0. Okay, so 0 0 is connected, means the output is 1. So 1 and D1 is the input to the NAND gate, this NAND gate. So the output will be 1 into D bar, which is D1 bar. Okay, so this is D1 bar. Okay, so before the we get denote here, before that what was the input available here? It was 0. 0 will flow here. Okay, 0 will flow here, and denote is coming from here. So 0 into denote is 0 complement, which is 1. Okay, 1 into denote, 1 into d1, the output is d1. So here it is coming d1. Okay, similarly here we can see it is 0 here. Okay, so after the clock and 15 nanoseconds, this output will change to d1. Okay. So this will change after 15 nanoseconds. Okay, okay, this is 0 here. So any of the input of the NAND gate is 0, the output is how much? The output is 1. Okay, this input is 1, this input is D2. 1 and D2 will become how much? 1 and D2 will become D2 complement. Okay, 1 and D2 complement, the output of this NAND gate will be D2 alone. Okay, so the here the input is D2, and we will get the D2 here. Similarly, you can evaluate this and we will get the similar data. So this is how we are writing this. Okay, now if we have understood this writing operation, let's talk about the shift operation. Okay, to operate this in the shift mode, so this is shift should be 1. This signal should be how much? 1. Okay, so we have to shift some data. So let's say this is 1 1 0 1. Okay, so this data we want to shift outside. Okay, so this one is directly this the rightmost one is directly available, so we can read it directly. Okay, so let's see what happens at each clock. Okay, what happens at each clock? Anyone having any doubt, any problem till now? Okay. Okay. So we have kept it shift equals to 1. So what will happen? Okay. So these data, whatever they were, we are not interested in this. Okay. Now we want to see how the data is shifting. Okay. We may keep this data while shifting. We may keep this data to all 0 0. Okay, because our editor, we do not want to change the current data. Okay, so this operation is we can keep them 0 0 off. Okay, although they will not affect, I can show you, their whatever their value may not affect this circuit. Okay, or if they will affect, we will see what we should keep them. Okay, okay, I'm not keeping anything. Okay, the circuit will tell us we need to give them 0 or not. Yes, this circuit will tell us. Okay, is there any doubt to anyone? Okay, so the shift is 1 now. So shift, where the shift is connected, let me check, see, show that. So this line is connected here all the way. Okay, so this is here, the shift line is going. So for this, let's evaluate this first NAND gate, this NAND gate. So both the inputs are 1 of the NAND gate. So what will be the output? The output to the NAND gate will be 0. Okay, so this is 0 and the input is D1. So what will be the output here? The output here will be how much? The output here will be D1. Sorry, the output will be 0 here. Okay, because 0 and D1, 0 into D1 complement will give us 0 only. Okay, so here was the data was stored was 1. Okay, so here the data was stored 1. So what is coming here? This is 1, 1 and 1. Both NAND gate input is 1, so this will be 0. Okay, both the inputs of the NAND gate are 0, so this would be 1. Okay, this would be 1 here. Okay, so this is irrespective of the value of D1. You can see that what one we have got 1 here without assigning any value to this D1. Okay, we have got 1 here without assigning any value to D1. हमने D1 को कोई भी वैल्यू असाइन नहीं की है, हमने D1 को एज अ D1 ही लिया है, ना 0 असाइन किया है, ना 1 असाइन किया है. We have got. Okay, okay. So someone is saying that I have to upload this because initially there was some correction problem at their end. No problem. Anyways, I am uploading each and every lecture, so no problem for you. Okay. So this is 0 0. The output will be 1, and this one we are getting irrespective of the value of D1. D1 can be anything. Here we will get 1. Okay. So now let's talk about here. So what is this? This is D2 input. So this is D2 input. One more thing, we didn't talk about this flip flop. This flip flop, whatever value we choose for the D naught. Okay, whatever we choose 0 or D naught. So after the clock, here the data will be available as D naught. Okay, I am not assigning any data to D naught. The circuit will tell us what we should assign them so that there is a proper shift operation. Okay, there is a proper shift operation. I am keeping it D naught only. Okay, so this is the shift operation. Okay, so it means that what we can think here, that this data has shifted to this point, this data has shifted to this point, this one has shifted to this point. Here now we have 1. Okay, so this 1 is available here. As soon as the clock comes, this 1 will be appearing here. Okay, so the new one will come here after the clock. Okay, so what about this flip-flop? Again, we can see that here D naught is the input. This uh, what is this output? This output is 0. This line is 0. It means this is 0 means this is the whole line is 0 here and it is connected here. This is 0 and D naught. 0 and D2 is the input to this NAND gate. So this will output will be 0 into D2 complement. 0 into D2 is 0. Complement is 1. So the output will be 1. Okay. So you can see the output of this line is 1 irrespective of the value of D2. Whatever we apply at D2, it doesn't matter, the output to this is 1. Again, what is available here is, okay, so the same 0 is connected here. Okay, the same 0 is connected here. So here it is 1. So whatever the, since you know that if one of the input of the NAND gate is 0, okay, you should remember this. One of the input to the NAND gate is 0, the output will be 1. Okay. So one of the input is 0, so we don't need not to see the another output, the output will be 1. So both are 1, 1, the output will be 0 here. Okay. So you can see that after the clock, okay, so this input is now 0 and once the clock comes, this will remain 0. One, 1, 0. So this should change to, it was initially 0, 1, 1, 0, 1. So it should change to move to the next state. It should move here. Okay, let me check this logic circuit again. Okay, so what we have kept it here. Here the input shift. This line is 1, so the output will be 0, and this is 0 means, and another input is D1, so the output will be not 0. This output will be 1. Okay, this is mistake. Yeah, this is mistake here. So this is both the inputs to this 0, so the output will be 1 here. If any one of the input is 0, the output will be 1 here. Okay, so the output will be 1 here. So to one of the input is 0, so the output will be 1 here. So we can see that this 1 is shifted here. Okay, and whatever the data we have kept at D naught will be available here. Okay, maybe 0 or 1. We are not interested right now. Okay, so the you can see that 1 is here. So as soon as the clock comes, so this is the new one. Okay, quickly the time is running out. We can take the attendance in the WhatsApp group. Okay, so this is 1 now. This is 1, and this output is 1 here, and this output is 0 here. Remember, this output is 0 here. Okay, so this is 0. Okay, so this is 0 means this output will be 1, and yeah, this output is 0 and this output is 1. This line is 1. Okay, and this line is 1, 1, 1, 1, 1, 0. This will come out to be, okay, this input is 1, this input is 1, so definitely the output will be 1. So with one of the input is 1, another input is 0, so the output will be 1 here. The output will be 1 here. So here it will be 1. And you can see that clock comes, this will 1 will reach here. Okay, so the new outputs are 1, 1, and on the left is 0. So how the 0 will move to the right side, this we have to see. I don't know, it will continue or the meeting will stop. Okay, so quickly we see it here. So what is this? This is 1, 1 and D3. No, sorry, this input is 0. This is the mistake. This input is 0. So this is 0 is going here. 0 and D3, the output will be what? 0 into D3, the output will be 1. Again, here it is, what it was, 0. Okay, so 0 here, 0 here, and this is coming 1 from here. So the output will be 1 here. 1, 1 output will be 0. Okay, and as soon as the clock comes, so this will change to the 0. So you can see that the data is shifted right side, 1, 1, 0, and we can take that edge 1 directly outside. Okay, so this is how it is working. You have to just don't confuse with the number of signals. You can understand. I advise you to write this signal by yourself. Draw the circuit diagram on a pen and paper, and then do the operation by yourself. That will make you understand, and you can explain it, and you can write in your words after understanding it. Okay, so